Okay, so in this video, I'm going to teach you how to factor quadratic expressions of the form x squared plus bx plus c. So note that this is a very specific type of quadratic expression because we are limiting the value a, supposed to be an ax squared, but we're limiting the value of a to be 1. So that's why it will be x squared plus bx plus c, where b can be any number and c can be any number. Okay, so I wanted to create this video for factoring quadratic expressions because this is one of the most important skills that you have to learn in algebra. You will apply this even in trigonometry, you will apply this even in geometry problems, even in calculus problems. So you need to know how to factor quadratic expressions. Okay. Okay, later on I'll show you how to factor those that follows the ax squared plus bx plus c. But for now, let's focus on a is equal to 1. Okay, so I'll teach you how to factor the more general expressions later on. Okay. Now, to understand factoring quadratic expressions, we have to understand it from expanding expressions, because these two are connected topics. They're actually opposite or reverse process or operation. Prior to learning quadratic expressions, you learn how to multiply expressions like x plus 2 times x plus 3. And your teachers or teacher might have taught you different ways on how to expand. Okay, so one way to expand, if your teacher introduced the FOIL method, it means we multiply the first. That means you get x squared. You multiply the outer, x and 3, that's positive 3x, we write plus 3x. I means inner, 2 times x, positive 2x or plus 2x. And L means the last, the 2 and 3, which is equal to 6, so we have plus 6. Okay. And then we have to add expressions that are similar, or terms that are similar. So that means x squared, 3x and 2x can be combined into 5x and then plus 6. Okay, so that's how we expand expression when we have two binomials being multiplied. So in factoring quadratic expression, we're basically doing the reverse of the process. Okay, so you start with x squared plus 5x plus 6. So the expression, the trinomial expression or the quadratic expression x squared plus 5x plus 6, you have to note that this came from two binomial factors. So that is why you will expect that this will be, or the factored form will be, in this format. We have two binomial factors. And take a look at the first term. Okay, let's go back to the expanded version. Okay, from x plus 2 times x plus 3 going to x squared plus 5x plus 6. Note that x squared is just the result of multiplying x and x. So if we will reverse the process, it means the first term of the binomial factors will be x and x coming from the x squared. And note how we got the 6. The 6 is basically the product of 2 and 3. So that means we can have 2 and then 3. Okay, but since 6 is a positive number, there are two possible cases that you can have. It's either the 2 and 3 are both positive or 2 and 3 are both negative. But how do we know? The sum, the 5x, must be a positive number. Okay, now in order for this to be a positive, the 3x and 2x, those outer and the inner product should be positive. And we have to force the 2 and 3 to be positive. So that's how you go back. Okay, again, the x squared, this x squared will have x and x, first and first. the 6 will be the last and the last. So 2 and 3. Now you might say, there are other factors of 6 aside from 2 and 3. We can have 1 and 6. How come we did not use 1 and 6? Or how do we know if the right numbers are 2 and 3 and 1 and 6? Well, the key is, when you check what two numbers, when multiplied, will result to 6, you have to consider that the sum of the two numbers should be the number or the coefficient of the middle term. However, 1 plus 6 is not 5, and it's equal to 7. So we do not consider this combination of numbers. Okay? So let us simplify the explanation furthermore. X plus 2, or rather x squared, plus 5x plus 6, and I'll repeat the process. We will have two binomial factors. The first coming from x squared, x times x. The 6, or the numbers here, will come from 6. So we have to think of two numbers when multiplied becomes 6. So we think of 2 and 3, or 6 and 1. Then we test which of the pairs of numbers will be the correct combination. We have to add them, plus 3 and 7, and that number or the sum should be the one in the middle. If that will give the value 5, or the pairs give the value 5, then those are the numbers that we need. So we place 2 and then we place 3. Both of them are positive. So that's how you factor an expression. Okay, let's take a look at another example. Okay, let's have something with negative. Example number 2. So you are given x squared minus 7x minus 18. Okay, so immediately you can expect this to be of this form when factored, because a quadratic trinomial, resulted from two binomial factors. Okay, the first terms of which will come from x squared, x and x. The last will come from 18, negative 18 to be exact. So to get a negative 18, you have to identify factors of negative 18 that will result, however, to the sum equals negative 7. So we could think of, maybe it's a combination of 6 and 3, when it's 6 is negative, 3 is positive, or maybe 6 is positive and 3 is negative. What else? We can have 18 and 1, negative 18, positive 1, or positive 18, negative 1, or even negative 9 and 2, or 9 and negative 2. So there are actually 6 pairs of numbers that we can choose from. However, our guide is this. The sum of the numbers in the pair should be equal to negative 7. Now take a look at negative 6 and 3. The sum is negative 3. This is not what we need. This is 3. This is negative 17, the sum. This is positive 17. This is negative 7. This is positive 7. And it is very clear that the combination of numbers should be negative 9 and 2. So that means our factored form should be a minus 9 and a plus 2. So that's how you factor. You can always check, multiply the expression or the binomial factors and hope that it will result back to x squared minus 7x minus 18. See? So that's how you factor an expression like this. Let's take one more example. Something with a negative and a positive. Okay, example number 3. So again, take note that we're just factoring expression of the form x squared plus bx plus c, specifically when a is equal to 1. Okay, so this method works for x squared plus bx plus c, that is when a is equal to 1. Okay, so what if we have x squared minus 16x plus 63. Okay, so we have seen two positive numbers, and then we have seen a negative and a negative, this time a negative and a positive. Okay, so if you inspect the trinomial, it's of the form x squared minus 6 x squared plus bx plus c, so you can expect it to be factored in this way. So again, the first term will always come from x squared, x and x, and all you have to do is to find the combination of numbers for the 63. So give me two numbers immediately. Okay, so we will not try to list them all now. Our goal is the moment you select a pair of numbers, you check it immediately if it will give you 16. Okay, 63 can be obtained from 9 times 7. It can also be taken from negative 9 times negative 7, because a positive number can be coming from a positive times a positive and a negative times a negative. So the next check is the sum. The sum of 9 and 7 is 16. The sum of negative 9 and negative 7 is negative 16. So this is the pair that we need. So simply supply those numbers. So minus 9 and minus 7, and you're done. Okay, so that's how easy it is to factor expressions of the form x squared plus bx plus c. Okay, let's take a look at more. Okay, we already have, so in the first, it's a plus and a plus, meaning plus and plus. In the second, we had a minus and a minus, as you can see here. And then we also had a minus and a plus, I think, on the third. So what about a plus and a minus? Okay, so let's find more examples. Okay, I think one more. Example number 4. So what if we have x squared plus 3p minus 10? Okay, upon inspection, it follows x squared plus bx, not 3p, plus 3x rather. So plus 3x minus 10. Okay, so it's in the form x squared plus bx plus c. Okay, so we can already prepare the factor form. So two binomials. Again, the first terms will come from x squared. So x times x is x squared. And then we just have to find the right combination for the 10 with the guide of 3. Okay, so negative 10. Okay, you carry the sign, negative 10. Two numbers, when you multiply, becomes 10. Well, 5 and 2, but not just 5 and 2. One should be negative and the other is positive. Or it could be the reverse, 5 and then negative 2. So you can list down all the combinations, but try to check immediately if these are the numbers that you need. Okay, just to save time. So negative 5, when you check the sum, you have to check the sum. Negative 5 and 2 will be negative 3. 5 and 2 will be positive 3. And again, look at the middle term. It's a plus 3x, a positive 3. So these are the combinations that we need, or the combination that we need. Okay, so that means you can easily now supply plus 5 and then minus 2, and we're done. So that's how you factor expressions of the form x squared plus bx plus c. Okay, I have 4 examples, different kinds or different format, combination of signs, positive, negative, 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 positive, negative, or negative and positive. So all the process is basically the same. Okay, but again, always check, because this is a very specific kind of ax squared plus bx plus c. We restricted it to a equals 1. There are also expressions where a is not equal to 1. Okay, but I am planning to do that in a different video, so it will not be confusing. Okay, so I think that's it for factoring. I hope you understand now how to factor quadratic expressions of the form x squared plus bx plus c.